I got some questions on topic 6, paper 1. So we're going to start with number 3. And I want you to see that it says that excess magnesium was added to a beaker of aqueous hydrochloric acid on a balance. A graph of the mass of the beaker and contents was plotted against time. So what you're seeing is that the mass decreases even though you're adding hydrochloric acid. Obviously there's a reaction that's taking place, which is converting something to a gas. And as a result, some of the substances being released into the environment, and that's why the mass decreases. So the question has to do with what would result in line 2 versus line 1. What would cause the reaction to happen faster and the mass the mass of the beaker to decrease faster? That's what that's showing. So if we look at the options, it says what changes in the experiment would give line 2. So if you use the same mass of magnesium but in smaller pieces, it's still going to be the same amount of magnesium that you're starting with in the beaker. So that's not really going to give you line 2. And then the second one says the same volume of more concentrated solution of HCl. That HCl, if it's more concentrated, it's going to break down the magnesium faster, and that would result in the line number 2, which goes faster. And then you've got number 3, a lower temperature. A lower temperature is going to make particles move slower, not faster. So that would not be the correct answer. So the only correct answer there is letter B. 2 only. The same volume of a more concentrated solution of hydrochloric acid. Number 5 asks which of the following is or are altered when a liquid at its boiling point is converted to a gas at the same temperature. Well, you have to think that when a substance is going from solid to liquid to gas, what is happening to the particles? They are not changing in size. The size is the same. But as they go from solid to liquid to gas, they do separate farther. And you know that because in a solid, they're very closely tight together. In a liquid, they're flowing a little bit more, but they're moving a little bit more away from each other. And in a gas, they're separated and bouncing off of each other. So definitely number 2, the distance between the molecules. So if I look at my options right there, I can look at number 3, the average kinetic energy of the molecules. But if I know that Roman numeral 2 is for sure an answer, then my only options are either B or D. And we already said we know the size of the molecules is not going to change. So it's definitely not D. So the only correct answer there is letter B. On number 9, it asks which statement is correct for a collision between reactant particles leading to reaction. So you have to think about the collision theory, and you have to think about the diagram where they go over the hill to reach the activation energy, the transition state, and then they go to the other side. So it says colliding particles must have different energy. Not necessarily. They could have equal energy. They just have to have sufficient energy, right? It says all reactant particles must have the same energy. Again, not true. They could have different energy, but they have to have sufficient energy, enough energy. So neither A or B are correct. C, colliding particles must have a kinetic energy higher than the activation energy. So in order for particles to lead to a reaction, they have to overcome the activation energy. So that is true. Colliding particles must have kinetic energy higher than the activation energy, or equal to, because they need to get to the top and then be able to move to the other side. So C is correct. D, colliding particles must have the same velocity. Again, not necessarily true. One could be going slower than the other, but they just have to have sufficient energy. So the collision theory does not say anything about velocity. So letter C is the correct option for number 9. On number 11, it asks you to compare rates, and I want you guys to look at what's happening. You should look at the coefficients in the reaction 2A to 1B, and then it forms 1C plus 2D. So those are important to note. I want you to see that these are all the concentrations at the beginning of the reaction, and then after 1 minute, these are the concentrations. So let me talk about that a little bit. First of all, there are six. The concentration of A is 6 at the beginning. The concentration of B is 3 at the beginning. And then there's no C or D. C or D are formed later. That's why it goes up to 1 and up to 2. So right there, even just from that information, I can rule out Roman numeral 3, because C does not go down. See how this is -2, -1, -1. This is -2 for A, -1 for B, and -1 for C. Well, this is not negative. It doesn't go down, it goes up. So right there, right away, I can rule out Roman numeral 3. So I know it's not that. So this does not go down 1, it goes up 1. This one does go down 1. So for B, it is true that it's -1. And this one, if you look at the, it does go down 2, -2. So this one goes down 2, -2. This one goes down 1, -1. This one goes up 1, +1. So the only one that's not correct is Roman numeral 3. So the correct answer for that one would be letter A, 1 and 2 only. 14 talks about at 25 degrees Celsius, you have 100 centimeters cubed of 1 molar hydrochloric acid added to 3.5 grams of magnesium carbonate. If the sample of magnesium carbonate is kept constant, so you don't change the magnesium carbonate at all, which conditions will not increase the initial rate of reaction? So I want you guys to see that it's not, if you increase the concentration, then that is going to potentially cause, let me see, what does it say? Will not increase. So we're looking for the one that will not increase. So increasing the concentration is definitely going to increase the rate. So if you look at B and D, both of those made the concentration go from 1.0 to 2.0. Doubling the concentration, which means the strength of that acid, is definitely going to increase the rate of reaction. So we can rule out B and D are not correct, because we're looking for the one that's not going to increase the rate of reaction. Okay, now, if we look at letter C, the reason I know letter C is going to change the rate of reaction is because the temperature increases. See how it's the only one that goes up. All the other ones are at 25 degrees. They're keeping the temperature constant. Letter C is increasing the temperature by 10 degrees. That is not going to, that will increase the initial rate of reaction. And we're looking for the one that's not going to increase the initial rate of reaction. So letter A is the only correct answer. The concentration, they did not use a stronger concentration, and they also did not change the temperature. The only thing they do is use more HCl, but that's not going to change the initial rate of reaction. At the beginning, that's what initial means, right? At the beginning, even if you add more HCl of the same concentration and at the same temperature, it is not going to increase the initial rate of reaction. So the answer for that one would be letter A.